Remember the days of dial-up internet, the screeching sound, the slow-loading pages. Behind that was a room, probably in an office basement filled with humming, blinking servers. That was the data center of the past, a glorified, air-conditioned closet. Fast forward to today, and that closet has transformed into the invisible backbone of our entire digital world. From your latest binge watch on Netflix to the complex AI models changing medicine, it all lives inside a data center. But what we have now is just a stepping stone. The future of data centers isn't just about getting bigger, it's about getting smarter, faster, and surprisingly, greener. Stick around, because we're about to journey from the server rooms of the 90s to the mind-bending data hubs of tomorrow. Let's take a quick trip back in time. The earliest data centers were monolithic beasts. Think massive mainframe computers, each one taking up an entire room, managed by people in lab coats. Companies owned and operated everything themselves. If you needed more power, you had to buy another huge, expensive machine, find space for it, and figure out how to cool it. It was slow, inefficient, and incredibly expensive. Then, in the late 90s and early 2000s, came the dot-com boom. Suddenly, everyone needed a website, and the demand for servers exploded. This led to the rise of colocation facilities. Think of them as apartment buildings for servers. Companies could rent space instead of building their own data center from scratch. This was a big step, but the real revolution was just around the corner. The game changer was virtualization. This technology allowed a single physical server to act like multiple virtual servers. It was like discovering you could build several apartments inside a single family home. This innovation paved the way for the cloud. Giants like Amazon, Google, and Microsoft realized they could use virtualization on a massive scale, creating what we now call hyperscale data centers. These are sprawling campuses, some the size of small towns, packed with hundreds of thousands of servers, all working in perfect harmony. They offer incredible power and flexibility on a pay-as-you-go basis. This shift from owning physical hardware to renting virtual resources is the single biggest change in the history of data centers. It democratized computing power, allowing a startup in a garage to access the same infrastructure as a Fortune 500 company. So, that brings us to today. We live in a world powered by these hyperscale cloud data centers. They are engineering marvels, optimized for efficiency and reliability. But the demand for data is growing at an exponential rate. Think about it. High resolution, video streaming, the Internet of Things with billions of connected devices, and the insatiable appetite of artificial intelligence. All of this generates an unimaginable flood of data every single second. The current model of sending all this data to a centralized cloud, hundreds or even thousands of miles away, is starting to show its cracks. The biggest problem is latency, the time delay it takes for data to travel. For watching a movie, a few milliseconds of delay doesn't matter, but for a self-driving car that needs to make a split-second decision, or for a surgeon performing a remote operation using a robot, any delay can be critical. This is where the next evolution begins: edge computing. If the cloud is the centralized brain, the edge is the local nervous system. Instead of sending all data to the central cloud for processing, edge computing processes it closer to where it's created. This means smaller, more localized data centers are popping up everywhere, in factory floors, at the base of 5G cell towers, in retail stores, and even in our cities. These edge data centers handle the time-sensitive tasks locally, reducing latency to near zero. Imagine a smart factory where sensors on a machine detect a potential failure. Instead of sending that data to the cloud and waiting for a response, an edge server right there on the factory floor can analyze it instantly and shut down the machine before it breaks. That's the power of the edge. It enables real-time applications that were previously impossible. So, the future isn't a battle between the cloud and the edge. It's a partnership. The massive hyperscale data centers will continue to be the workhorses for big data analytics, long-term storage, and training complex AI models. But they'll be supported by a vast network of these smaller, nimble edge data centers handling the immediate real-time processing. It's a hybrid model, giving us the best of both worlds: the immense power of the central cloud and the lightning-fast responsiveness of the edge. This distributed architecture is the blueprint for the next decade of digital infrastructure. It's what will power truly smart cities, autonomous transportation, and next-generation augmented reality. But there's a huge challenge we need to talk about: power and sustainability. Data centers are incredibly power-hungry. In fact, globally, they consume more electricity than some entire countries. As we build more and more of them, this energy consumption is becoming a serious environmental concern. The future of data centers absolutely depends on our ability to make them green, and the industry is responding with some incredible innovations. We are seeing data centers being built in colder climates like the Nordics to take advantage of natural cooling, drastically reducing the energy needed for air conditioning. Some are even being built underwater. Microsoft's Project Natick submerged a data center off the coast of Scotland. using the cold seawater to keep the servers cool. The results were fantastic, showing higher reliability and efficiency. Beyond just cooling, the very way we power these facilities is changing. We're moving towards renewable energy sources like solar, wind, and geothermal. Many major tech companies have pledged to power their data centers with 100% renewable energy. Another fascinating concept is waste heat recovery. Data centers generate a lot of heat. Instead of just venting it into the atmosphere, innovative projects are capturing this waste heat and using it to warm nearby homes, offices, and even greenhouses. Imagine a data center not just processing your data, but also helping to heat your city in the winter. That's a truly sustainable vision. The goal is to create a circular economy for energy, where the byproducts of computing become a valuable resource. And what about the servers themselves? The hardware inside is also getting a radical makeover. For decades, we've relied on silicon-based chips, but we're reaching the physical limits of how small and fast we can make them. So, researchers are exploring new frontiers. One of the most exciting is photonic computing, which uses light instead of electricity to process and transmit data. Light is incredibly fast and generates far less heat, promising a massive leap in speed and energy efficiency. Another game changer on the horizon is liquid immersion cooling. Instead of blowing air over servers, this technique involves submerging the entire server rack in a special, non-conductive liquid. This is vastly more efficient at removing heat than air, allowing us to pack components much more densely and run them faster without overheating. It looks like something out of a sci-fi movie, but it's already being implemented in high-performance computing environments. Finally, let's talk about the role of AI. It's ironic, AI is one of the biggest drivers of data center growth, but it's also the key to making them more efficient. AI algorithms are now being used to manage the data centers themselves. They can predict workload fluctuations, dynamically allocate resources, and optimize cooling systems in real time to use the absolute minimum amount of energy necessary. An AI can monitor thousands of variables per second: temperature, humidity, server load, energy price, and make micro adjustments that a human operator never could. It's like having a super intelligent engineer constantly tuning the entire facility for peak performance and efficiency. This AI-driven automation is crucial for managing the complexity of future hybrid cloud and edge ecosystems. So, where is all this heading? The data center of the future will be a stark contrast to the ones we have today. It won't be a single, massive building. It will be a distributed, intelligent, and sustainable network. We'll have underwater data centers cooled by the ocean, edge nodes in our neighborhoods for instantaneous response times, and massive hyperscale hubs powered entirely by renewable energy, with their waste heat warming our communities. Inside, servers cooled by liquid and running on light particles will be managed by sophisticated AI. It's a future that is faster, smarter, and greener. The invisible engine of our digital world is getting a revolutionary upgrade, and it's going to unlock possibilities we can only just begin to imagine. Thank you so much for joining me on this look into the future of data centers. It's a topic that might seem technical, but it underpins everything we do online. If you found this interesting, please hit that like button and consider subscribing for more deep dives into the technology that shapes our world. I'd love to hear your thoughts in the comments below. What future innovation are you most excited about? Thanks for watching, and I'll see you in the next video.